So when we have numbers, let's say I have a number 453, we can break it down into its place values and its periods. So a period is a string of three numbers like this. And in this instance, since there's no other numbers to the left or right, this is going to be my ones period. And each of these numbers can be broken into its own separate part. So where the 3 is going to be the ones. So I'm just going to put an O right above it, or the one spot. The 5 is in the 10 spot. I'll put a T. And the 4 is in the 100 spot. I'm going to put an H. So I'm going to extend this numbers out, and after we do one period, we put a comma, and then we can then extend it. So I can put, let's say, a 7, and this will now become its own period. Even with it only being one number, it's still its own period because it's in a different section from the ones. So this will be 1,000, and this period is the thousands. So there's a common rule when we're doing periods. So the first one will always be the name of the period. So this is the thousands, and this is 1,000. And then if I were to add another number, the 4, this will be then the 10,000s, or I'll put T for 10 and then 1,000. And then if I were to put an 8 to the left of that, that would be the 100,000. So the furthest number to the left in a period is the hundreds, and then that period name. In the middle is going to be 10, and then that period name. And then the first number, or the far right number, is going to be the period name itself. And I'm going to extend this to the next higher period. So I'm going to write down three numbers. Let's say 923. So this is the million. And if you were to guess, for the 3, since it's the far right one, it's going to hold its own period name. So it's going to be M. And then the place value name for 2, if you remember, is going to be 10 and then million, or 10 then place or period name. And then the one on the far left is going to be that 100 then million. And then we can do one more section. This section is called the billions. And if you remember the pattern, I'm going to get billion, 10 billion, and then 100 billion. So this does extend to the right. And let's say I have 1, 2, 3, and 4. So to the right, or these numbers, are going to be called the decimals. And this will extend no matter how many numbers you have to the right of the one spot. So this follows a similar naming convention to the ones, so it goes ones, tens, hundreds. It's actually going to skip the one spot and go straight to tens, and then hundreds, thousands, and then 10,000s. So it's going to carry the same naming convention. However, at the end of each name, so for this first 10 spot, this is going to be tenths. And for the hundreds, it is actually going to be hundredths. And if you could guess the last one for thousandths, it's going to be thousandths. So I'm going to quickly erase all of this, and then what we're going to do is I'm going to write out a number, and then we're going to place it in this convention, breaking it apart in its placeholders and its periods. So I'll have a number 1, 2, 4, 5, 6. So how we read these numbers is we're going to go starting from the right to the left and break them into threes. So I can group up starting from 6. So I got 6, 5, 4. That's a group of 3. And then I had two groups after that, but even if it's not 3, as long as there's at least one number after it, it's still going to be its new group. And this is going to be the thousands. And this is going to be the ones. So when you're reading it, your first group starting from right to left is going to be your ones, and then thousands, and then so on and so forth. And when you have just two numbers or one number filling up a section, you can write the rest as zeros if you want to, if it makes it easier. So now I'm going to put the comma to show that there are two different periods, and then we're going to write the placeholders. So we have the ones, the tens, hundreds, thousands, and 10,000s. So I'm going to quickly do one last example of this. So I'm going to write the numbers 5, 0, 6, 1, 0, 3, 0, 1, 2. And then so all the numbers to the right of this decimal are going to be placed in its own category. And remember, it's the decimals. So I'm just going to label it as D. And then I'm going to count from the period or the decimal to the left. So 301, place that in its own, and then 506, place that in its own period. And the first one, 301, is going to be the ones. I'm going to write it as a O, and then the 506, since it's to the left of the ones, it's going to be the thousands. Do a T, and then the 5 is going to be 100,000. The 0 is going to be 10,000. The 6 is going to be the thousands. This 1 is going to be the hundreds, this 0 is going to be the tens, and this 3 is going to be the ones. And then if you remember the naming convention for the decimals, you start at the tens instead of the zeros. And then you add that THS to the N. So this 0, instead of being tens, is going to be tenths. This 1, instead of being 100, it's going to be hundredths. And this 2, instead of being thousands, is going to be thousandths. So I'm going to erase this, and we're going to do an example using words, and then taking that words and bringing it into a numerical meaning. So I have this number written out, and we're going to put it into numerical form. So I'm going to start with the 4 million. So since there's no hundred or any number bigger than it, I'm just going to write down the 4, and then I'm going to place it in its own period. M for million, and then I'm gonna go to the next one. So the way it's going to be structured is you'll have a number in the hundred spot, 1 through 9. In this instance, I have 2. I'm gonna write that down. And then I know it's 1,000 since at the end it says 1,000, so I'm gonna write 100,000 above it, and then put it in its own period since I have another number after that. And then they will combine the tens and one spot into one number. So in this example, it's going to be 58. That 50 is 5 in the 10 spot, so we got 10,000. And then that 8 is going to be in the thousands spot for the thousands period. And then we're going to do this one more time. So I have 463. So I have that 4 in the hundred spot, and then that 63, so I can break that up. 60 is going to be 6 in the 10 spot, and that 3 is going to be 3 in the 1 spot, all for the ones period. And then the way decimals are set up, if you remember, they're one place value over, starting from 10. So we still write from left to right as we were. So this 900 is actually going to represent the 10th spot. So write the 9, I put the T for the 10th spot, and then the 20 is going to be after that, and the 20 will represent the 100th spot. And then since 20 ends in a 0, I'll put the 0 for the 1000th spot, and then I'll put it in its own period for decimal. And that'll be the example. The last part of this section is rounding, and it's to help make numbers easier to read. So we usually use this for larger numbers. So an example of this would be if I want to round 1053. So what I'm gonna do is I'm gonna round to the 100 spot, and when we round to the 100 spot, we look one spot over to the ones, and then we look at that number. So if it's a number 1 through 4, you're going to round down, which means you're gonna keep your current number. And if it's a number 5 through 9, you're going to round up or to the. So for this 1053, after rounding, it'll just be 1050. And then if I were to do an example of rounding up, let's say at a number 967, and then I'm going to round that 100 spot again. So I'm going to look one over to the one spot, and it is a number 5 through 9. So that means we're going to round up, and when I round up, I'm going to get a final answer of 970. So a multiple is a certain number multiplied by a whole number. So when I'm doing, let's say my certain number is 10, and my multiple is 2, I'm going to do 10 times 2 equals to 20. And if I want to find the multiple of 3, I'm going to do 10 times 3 equals 30. And the multiple of 4, using the same pattern, use 10 times 4 equals 40. So that's what a multiple is. Now, a factor is like the reverse of a multiple, where you want to find the two numbers that multiply together to get that number. So we're going to use 40 as an example. So we got that 40 by multiplying 10 by 4. So that means the factors of 40 are going to be 10 times 4. And these are my two factors. We can also break up that 10 that we use to get 40, since there are two numbers that multiply into 10 to get it, that being 2 and 5, and these are the factors that get us 10. Now let's say I want a number define its factors like 2 or 3. Well, you can only get that number by multiplying the number itself by 1, like 2. 2 can only be gotten by doing 2 times 1. That means it only has two potential factors, which means it is going to be a prime number. Unlike this number 40 over here that has factors, I'm going to put f of 10, 4, 2, 5, 20. This divisibility test will test what numbers a certain number can be divided by. So, for example, we're going to use the number 50. And there are a few tests. There's the test for 2, 3, 5, 6, and 10. For number 2, the number needs to end in either 0, 2, 4, 6, or 8. For number 3, the sum of all numbers needs to end in a number divisible by 3. For number 5, the ends must be 0 or 5. And for number 6, must be divisible by both 2 and 3. And for 10, the number must end in 0. And for 3, all right, all numbers added up equal number divisible by. So applying these tests, we can see that 2, 5, and 10 are all numbers that 50 is divisible by because it ends in 0. And if we do the test for number 3, we only get 5 plus 0, which is then equal to 5, which is not divisible by 3. So now I'm going to choose another number. This number is going to be the number 123. So it fails the second divisibility test because it doesn't end in those numbers. It fails the 5 and 10 because it doesn't end in either of those numbers. We can do number 3 and all the numbers added up. So 1 plus 2 plus 3 is equal to 6. So it does work for number 3. But it does not work for number 6 because it is not divisible by 2 and 3. Prime factorization is when you break up a number into all of its prime factors. If you remember, a prime number is a number like 2 or 3. And factors are numbers that, when multiplied together, will create the number that you're looking for. So in this example, we're going to be using the number 12. So the number 12 can be broken into two pairs of numbers, either 2 and 3 or 3 and 4. I'm going to choose 3 and 4. So what we do is we write the number 12, and then we put a little dash for a 3 and a little dash for a 4 to show that these are the factors. And we're going to look at both of the numbers. So 3 is a prime number, so we're going to circle it. And then 4 is not a prime number. It has two factors, that being 2 and 2. So we're going to do another one of those dashed lines or sets of dashed lines. And then we can break that 4 into another 2 and 2. And then with that, we're going to look at both of those numbers. We get a 2 and a 2. So both 2's are prime, so we're going to circle both of them. And since we can't break down any of the numbers further, we now have our final answer at 12 equals to 3 times 2 times 2. All right, so we're going to repeat this process, but with a larger number like 36. So we're going to set it up with that 36 at top. And then there's multiple ways you can split up 36. For this example, I'm going to choose 4 and 9. And then we're going to look at both sets of these numbers, 4 and 9. So I'm going to go on the left side first. So the 4, if you remember, can be broken up into its factors 2 and 2. And then the 9 can be broken up into its factors of 3 and 3. And we're going to look at all these factors. They cannot be broken up any further, so that means they must all be prime. So we're going to circle all of them. And then we have our final answer of 36 equals to 2 times 2 times 3 times 3. So we're going to do this process except with a lot larger of a number. And that number is going to be 144. And 144 has a lot of different sets of pairs for factors, but we're going to look at a larger number and see if it's even. If it's even, we can split it up into a pair of 2 and then a larger number that you can find by doing 144 divided by 2 or that large number divided by 2. So putting it through a calculator, I get 2 and 72. So that 2 is a prime, so I'm going to circle it and I can't do anything else with it. And then I get the 72. So the 72, I'm going to use the same process where I'm going to divide it by 2. And then I get 36. So this 2, I'm going to circle again. And I'm going to do the same thing with this 36, just to keep with the theme. So I get 2 and 18. I'm going to circle this 2. And then this 18, I'm going to do the same thing because it's even. 2 and 9. And then I'm going to do, I can't do that process one more time, but the factors of 9 are both 3, so I'm going to get 3 and 3. And since those are both prime, I'm going to circle both of them. And then we have our final answer of 144 equals to 2 times 2 times 2 times 2 times 3 times 3. And that will be. So now we are going to find least common multiples. So least common multiples are going to be called LCM, and it will be the least common multiple between two numbers. So I'm going to choose the number 10 and 15. So there's two ways to do it. One way is that you're going to take that number and then keep on using all of its multiples for the first and second number until they match. So for number 10, I got 20, or 10 times 2. And for 15, I got 15 times 2, which is 30. Then number 10, 10 times 3 is 30. And then 15, is going to be 45, or 15 times 3. And if we see here, we have both of them having 30. So that means our least common multiple is going to be 30. So now we're going to use a different method using prime factorization. So using prime factorization, I'm going to create the two trees of 10 and 15. And then I'm going to do the process. So I'm going to divide this by 2 and by 5. And then for 15, I get 3 and 5. So I have all their prime factors. So I have 2, 5, and 3, and 5. And then I'm going to set them up like this. So I'll put the 10s on top, 2 times 5. And then on the bottom, I'll put 3 times 5. So when we're putting the numbers together, we're going to try to put the same numbers on top of each other. So you put an arrow straight down and then you get 1. And then when you have two numbers that are not the same, you're going to not do that and put them separately. So we'll get 2 times 3 times 5, which equals to 30, which so I'm going to do one more example of finding a least common multiple using both methods. So I'm going to use the number 8 and 10. So I'm going to find the multiples of 8. So the multiple of 2 with 8 is going to be 16 for 2 times 8. And then 8 times 3 for multiple of 3 is going to be 24. And then the multiple of 4 for 8 is going to be 32. And then the multiple of 5 for 8 is going to be 40. And then I'm going to do the same thing for 10. So 10 times 2 is 20 for a multiple of 2. 10 times 3 is 30 for multiple of 3. 10 times 4 is 40 for multiple of 4. And 10 times 5 for multiple of 5 is 50. So I can circle the two like numbers for my LCM to get 40. Now time to use the prime factorization method. So I'm going to have my 8 and my 10. So I'm going to do 8, so I get 2 and 4. 2 is prime, but 4 is not. Its factors are 2 and 2. And then for number 10, I get 2 and 5 for its prime factors. So I can circle all the prime factors. I'm going to set them up in that equation. So get 2 times 2 times 2 on the top. And then on the bottom, I'm going to do that 2 times 5. So only 1, 2 will be brought right here, put that right here. And then I'll bring down this 2. And then I'm going to bring down this 2 along with the 5 because they're not the same number. And then I have my final answer of 2 times 5, which is that 10, 2 times 4, which is 4, and then 4 times 10, which is equal to that 40, which is the least common multiple that we got up here. So that will be the video. If you enjoy this content and have any suggestions for me to improve it,